Hello viewers, welcome back to another section of my multivariable calculus tutorial. In this video, we're still going to solve problems in finding the surface area of portions of quadratic surfaces. So I have a problem here. To find the surface area of that portion of the surface z is equal to y squared plus 4x lying above the triangular region R in the xy plane with vertices 0, 0, 0, 2, then 2, 2. So I've been given these vertices, and the region over which I'm going to integrate is a triangle. So how do we solve this? Watch every portion of this video, and don't make sure you subscribe, you like, and you also share. So first of all, to find the surface area, you know it's given by S is given by the integral, double integral of what? Our square root of fx squared, fy squared plus 1 dA, where fx and fy are the partial derivatives of this region we are going towards, sorry, of the surface we are going to find its area. Now, the next thing to do is to find out fx and fy. Given the function z, which is a function of x and y, and is equal to y squared plus 4x, the partial derivative with respect to x, fx, is simply given as 4. This becomes a constant and tends 0. The partial derivative with respect to y tends towards 2y, right? Yeah, so once you have this, then we proceed to finding our square root expression. So I'm going to have the square root of 4 squared plus 2y all squared plus 1, right? And this simplifies to square root of 16 plus 4y squared plus 1. Also equals 17 plus 4y squared. So the next thing to do is to find my limits. So given a triangular region, I can find my limit by drawing it in the xy plane, right? Yes. So let's draw this on the xy plane, and let's see. I'm going to have my plane here. So this is my y, this is my what, x, right? Yes. So the point was 0, 0, meaning it's going to fall here, 0, 0. The second point is 0, 2. So I'm going to have some 2 here, 0, 2. Then finally 2, 2. So 2 here, then maybe 2 here. So 2, 2, right? I'll join and get this triangle here. The next thing to do is to find the equation of each line bounding the triangle. So we realize that this place is equation s is equal to 0, equation y equals 2. Then this place becomes what? We solve for the equation. And any line passing through the origin has the equation y equals what? X, if it has a positive gradient. Now we have the equations. The next thing to do is to take one direction with which we are going to integrate over. So looking at our function, we are having s is equal to integral, double integral of our square root of 17 plus 4y squared dA. Meaning we have to integrate with respect to what? X first, so that we can have y to help with the computation of this expression. So I'm going to slice through x first. This is the boundary I have, or this is the region. So slicing through x, I'm going to start from here, then I'll cross this way. So you realize I'm starting from s equals 0 towards s equals y, so y. So x boundaries becomes s is greater than or equal to 0 and less than or equal to y. Then my y will be from 0 towards 2, right? So 0 less than or equal to y, less than or equal to 2. So once I have these boundaries, the next thing I'm going to do is to put it in my limit. Sorry, my integral. So integral 0 to 2 for the y, integral 0 to y for square root of 17 plus 4y squared dx dy. So this is actually what I'm going to do. So now the first integral is with respect to y, so I get x square root of 17 plus 4y squared, then from 0 to y dy, right? So I move on with my simplification, and I'm going to get integral 0 to 2. I'll put my y, 0 will make everything 0, so y square root of 17 plus 4y squared dy. This can be computed using some simple substitutions. So computing this is actually equal to, you let a variable u or any variable be equal to 17 plus 4y squared, right? So the u over the y is equal to 8y. Then you make your dy the subject, which is equal to 1 over 8y du. Then I'll introduce everything back here. So I'm going to get square root, so integral from 0 to 2 on y multiplying square root of u, right? Multiplying my dy is 1 over 8y du. Then this y, simply cancel this y. Then I'm going to get integral from 0 to 2. Then u to the power half over 8, right, du. So I have everything in terms of u. Then I simply put my, so I simply integrate this, right? So 1 over 8, then I'll add 1 to it, so 2 over 3, u to the power 3 over 2 from 0 to 2, right? So at this point I have 1 over 8 here, multiplying this 2 over 3, and multiplying my u was 17 plus 4y squared, all to the power 3 over 2 from 0 to 2. Then 2 go into itself 1 and go here 4, so I've left with 1 over 12, 17 plus 4y squared to the power 3 over 2 from 0 to 2. Then at this point I'll put 2, then I'll put 0. So putting 2, I'm going to get 1 over 12, 17 plus 2 squared will be 4 plus 16, or to the power 3 over 2 minus 1 over 12. Here will be 0, so 17 to the power 3 over 2. And this is giving me 1 over 12, 33 to the power 3 over 2 minus 1 over 12, 17 to the power 3 over 2. So computing this into your calculator gives you the solution of our surface area. This is the end of the video. Thanks for watching. Don't forget to like and subscribe.